This is chapter or unit 4, review problem 15, Beanstalks. Okay, so I'm going to assume that you've read over the problem. Basically, we're talking about the heights of males and females. And apparently there's some kind of organization or club that very tall people can be accepted to. Anyway, problem A. You're probably not surprised to learn that men are generally taller than women, but what does the greater standard deviation for men's heights indicate? So men have as you can see here, men have a larger standard deviation. So this is not intended for you to be a tricky question. It's just to remind you of what we're dealing with here. So the greater the standard deviation for men's heights indicate that men's heights vary more than women's heights. That's all. There's just more of a range of male heights. Women heights are more consistent, if you will. Okay? So that's A. That's all you have to do is say that men's heights vary more. Are men or women more likely to qualify for Beanstalk membership? Okay, so we have, I'm going to call it a threshold. So you must be over 6'2" to be in the women's club, the men's club, and over 5'10". So with the information that they've given us, they've also said that the distributions are normally distributed. So let me see if I can draw this out. I'm going to do large variability. So let's just say that this is men's. So the center is 6.9 or 69.1, and one standard deviation away is 71.9. 2 standard deviations is 74.7. And 3 standard deviations would be 77.5. Something like that. Okay, and so to be in the men's club, you have to be 6'2". So that's 74. So that's right about here. Okay? So these are the distributions of all men's heights. So now let's look at women. If you look at their distribution, their mean height, it's not very symmetric, but let's see, their mean is 64. One standard deviation is 66.5. 2 standard deviations is 69. And 3 standard deviations is 7.1. But 5.5 feet 10 inches is that's 70. So that's that's way out here. So, and I'm probably drawing that wrong, but look, it's about almost 3 standard deviations away, where men's is only, it's a little less than 2, or about 2. So it's going to be harder for women to qualify for this club. That's all that's really getting at, is that, you see, so if this was a club where tall men and tall women were paying membership fees to join so that they can meet somebody that's compatible, there's going to be more men. There's not going to be that many women, and there's going to be a lot more men. So it'll be a good deal for women. Okay, so enough on that one. C. They want us to define some random variables. So all you have to do for C is say something like, let M be the height of a randomly selected male. And then you would do something similar for W. Okay, and then, so I'm not going to do that just because I want to, this video is already going to be long as it is. So then we would, an expression for the difference would be M minus W. Okay, that would be the difference in heights. So that's how you would do C. So write both out. What is the mean of the difference? So now we're getting to something that we typically do. So men minus women, that's going to be the expected value of men minus the expected value of women. So that's going to be, what was it? 69.1 minus 64. So 5.1 inches. What's the mean difference? What's the standard deviation? Well, we have to work with variances. So the variance of men minus women is going to be the variance of men plus the variance of women. So we were given standard deviations. So for men it was, what was it, 2.8? 2.8, so it's 2.8 squared plus 2.5 squared. Okay, so the standard deviation of men minus women is just the square root of that. And I'm going to be lazy. 2.8 squared plus 2.5 squared. And I did it ahead of time on the calculator, and I get 3.75. Alright? So now, suppose a survey of married couples reveals that 92% of the husbands were taller than their wives. Based on your answer to part F, do you believe... Oh, wait. I'm getting ahead of myself. I did E. I need to do F. What's the probability that a man is taller than a woman? Okay, so what's the probability that a man is greater than a woman? Okay, so if you wrote it like that, then we would have to subtract W from both sides, and we get M minus W is greater than 0. So that's the probability of M minus W is greater than 0. Okay, so that's the normal model. We can use the normal model because they told us that these two variables are normally distributed somewhere up here. They follow a normal model. Okay, so then that means the difference follows a normal model. So we have a center of 5.1 with a standard deviation of 3.75. Okay, so this is going to be, you got to remember the Z calculation. This is going to be the probability that Z is greater than 0 minus 5.1 divided by the standard deviation, 3.75. So somewhere you have to memorize that this is our observed value, x, in this case our observed value minus mu divided by standard deviation. So what they're saying is that if you think about it, let's pull up the calculator for a second. If we have 5.1 minus 3.75, one standard deviation away is, what was it, 1.35. 1.35. And so 0 is going to be right about here. That's 0. So they're asking, what's the probability that it's great, that the difference is greater than 0? So this is a model of the difference. Okay, so they want us to find this area in here. So that's going to be the probability of z greater than, let's see, negative 1.35. So that's about what it is, 1.3 standard deviations away from the mean in the negative direction. So that's going to equal normal CDF. So you can get that by doing on your calculator second, I think it's distribute. Something like that, the blue button. On my calculator it's blue. Okay, so we want to go from negative 1.39 to infinity, right? Out to positive infinity. So 9,999. So that's going to be 0.913. Okay, so if we randomly select a man and randomly select a woman, there's a 91.3% chance that the male is going to be taller than the woman. Okay? Now, G, suppose a survey of married couples reveals that 92% of husbands were taller than their wives. Based on your answer to part F, do you believe that people chose spouses independent of height? Well, it's pretty close. It's pretty close. So I would say, I think yes. 92% was seen in the survey. That's so close that I would say yes. They look like they're independent. They've been independently chosen. Because if you consider sampling variability, 92% is pretty close to 91.3%. So the sampled value and the modeled value are very close. Okay, so the key here was to be able to apply the normal model. Calculate an expected value, calculate a standard deviation, and apply the normal model to find a probability.